Hello, can everyone hear me? Is everyone energetic after lunch? No one's sleepy? If I see anyone sleeping, I'll come and tap you. Welcome, this is the API first Agile Approach to Data Management session. That's the right session if that's the one you're looking for. If not, see me in the back after this and I will steer you in the right direction. First of all, a little housekeeping before we start. Obviously it goes without saying, please turn off or turn down the volume on your phone. We don't want any interruptions. Excuse me. For those of you that have not already downloaded the app, please do so, because you can fill out our survey. And you can also, I'll tell you, a while ago I helped someone find a colleague via the app, so you can contact each other. It's very useful, besides the fact that we'd like you to fill out the survey. Let's see, Q&A. So we have expert one-on-ones, we have expert one-on-ones just down. If you just go straight down, when you get to the end where the side meeting rooms are, there's a table there, and you can set up a one-on-one appointment with experts. Excuse me, and I encourage you to take advantage of this because we're fortunate to have this conference near our headquarters, so we have all our technical experts that are dying to answer your questions or explain things to you. So you just have to go down the hall here to the right and set up a one-on-one. And finally, we have built-in time for Q&A at the end of this session. And I'm going to hand it over to Eric Henham, who's our principal engineer here at MarkLogic.
Great. Audible? Am I? Great. Fantastic. We are good to go here. Okay, and this session is API First. Gary did a great summary of what API First is at the very high level in the keynote. Really about a mind shift more than different technology. Justin also covered it in the morning breakout session at kind of a cloud level. Cloud has multiple meetings. I'm going to take it down to a deeper level. What we mean in terms of agile data management and agile integration. We start with a business that's under stress. Inventory levels are too high. The e-commerce site is experiencing some competitive pressure. We know regulatory compliance is coming down the pipeline, and so on. A technical lead at our company named Carla has been making the case that the root cause for these business stresses in every case is an issue of data integration. For example, we're having excessive inventory levels because we don't have integration between our ordering system, our inventory system, our supply system, so we can't predict well enough when we're going to get to a level where we need to reorder. So we have to maintain excess inventory. So Carla makes her case, and the CIO response is, well, you seem to have some strong opinions about this. Why don't you take a little time and see what you can do about it? But that's okay. Carla doesn't shy away from a challenge. She reasons because the fundamental issue is data integration, it makes sense to start at the source with our data sources. And we're going to figure out, after we inventory our data sources, we're going to figure out a model that can integrate the data from these sources. After we have the model, then we can write some services that will expose out our data. So we'll have a service that exposes customers, another service that exposes products, and so on. And then finally, we can write applications that fulfill the business requirement by mixing and matching customers and products and implementing the business logic. So inventorying this data sources is pretty straightforward. You get your spelunking hat on and you go down deep. So the challenge we'll pick up here is at the modeling stage. So Carla calls in a few favors and puts together a work group with the best and the brightest to create a model that will integrate data. So they go off to have a think. And their challenge is to come up with a customer record that reflects all of the data about that customer from all silos. Now, this is actually a pretty challenging thing. We have to determine the identity of the customer. And the property used for identity of the customer in one system might be different in another. One system, it's their social security number. In another system, it's an ID assigned to them, or it's a name. And as Justin was pointing out earlier, names can get different variations. We could have first names that are expanded or nicknames. We could have typos and so on. They also need to determine the semantics of what is a customer. In a business-to-business system, the customer is an organization. In an e-commerce system, the customer is an individual, and we don't want to call them both customers. They'll have different properties. We need to distinguish those. In short, the modeling team has to figure out the semantics, the vocabulary, properties. They have to tease all this out. But they come back fairly quickly. And they want to share some work in progress. They're pretty excited about it. And the big reveal is it all starts with thing, and then you distinguish physical thing and non-physical thing, and then everything else all falls out from there. So this does not go over great, of course, but the modeling people kind of stand their ground. They say, we need this, and the reason we need this is we're trying to build an enterprise-wide model. And it's a model of such size and complexity that no person could have the whole model in their head. So we need abstractions that we can use for consistency checks. And if we find that an entity is both a physical thing and a non-physical thing, we know we have a logical contradiction in our model. So they're pretty tenacious about this argument. But the light bulb for Carla, as she's listening to them, is that we're starting with too big of a problem. We're trying to solve too much at once in our first step outside. Moreover, we don't have enough executive support that we're going to be able to spend a year defining this model. It will never happen. And that kind of segues to some other second thoughts Carla is having about the data-first approach. Does it really make sense that we have to integrate all of the data before we get any benefit out of it? How about the data that we integrated but we didn't find a use for it? Our effort in integrating that data was wasted. There was no point in doing it. We also lost the opportunity to get feedback from our early mistakes. The data-first approach assumes we're going to be perfect, and of course we're not going to be perfect. Carla's also having some second thoughts about the services in this model, because the services are exposing the entities directly, customer and product. So if an application needs to put customer and product together, does that mean we need to download customer and product to the application and do joins on the application side? That's going to be terribly inefficient. Also, there's no business awareness, no business logic in these physical services that we're defining here. So that means that the intelligence, the business awareness has to be in the application. And do we really want to require all of our application developers to become business experts? In short, really the fundamental problem is we're starting with what we've got, with the data. We're not starting with where we want to get to. What are the benefits we want to get from our data? So Carla's not adverse to a course correction when she sees it's necessary. So she reasons, you start with the application. What business value do we want to get? From the application, you figure out what APIs do I need to support this application. Based on the APIs, what are the data operations, the data services that have to be executed on the persisted data so that I can have those APIs available to my applications? Based on the operations we need to perform on the data, what's the persisted model? What is the data we actually need, the minimum data we need to be able to support these APIs? And then finally, based on the model, what silos do I need to integrate? And it all plays out reasonably from there. So we're going to start with the applications. And there is a wish list of applications in this business that they'd like to get to. So Carla takes a look through the wish list, and kind of as Justin was teasing out earlier today, the magic quadrant is, in this case, in the bottom right. We want to have the least effort to implement, the greatest value to the business. And the one that leaps out is dynamic pricing, because it's something that will help us be more competitive in our e-commerce site. So Carla has a chat with the pricing engine people, and I should say there's already a batch pricing engine. It takes a couple days to run, it's run once a week, and it provides the static prices that we have now. But when she talks to them, it turns out that part of that logic, if you could supply it with the data that it needs, it could calculate a real-time price. It's actually code that's sitting in a loop currently, and it gets called many, many times, but they could expose another entry point, and we could just call it once if we can get it the data that it needs to calculate the dynamic price. So this is going to be our candidate for our first API. So what does the application need when it wants to provide a dynamic price? It's going to be able to ask for a customer and a product, what's the price? So the API has to take the identifiers for the customer and the product, and it needs to be able to call into the pricing engine, get the dynamic price, and return it back to the application. So the next step is, okay, for our pricing engine, how do we convert the customer and product identifiers into the factors that the pricing engine needs to calculate the price? So that's where we need data services that will look up those factors for the customer and product and return them so that the pricing engine can be called. So to look up the factors, that gives us the model that we need and thus the sources that we need to integrate to provide our customer data and price data and product data to fulfill this first API. So Carla puts together a team, and the team chooses to stand up this stack in the cloud, partly because the clock is ticking, partly because there isn't a long-term commitment. This is a project that has to prove itself. So because the pricing engine is written in Java, the API will be implemented in Java. That is the application-looking portion of the API. And the part of the API that works with the persisted data will be implemented in JavaScript, in SJS, on the MarkLogic node. So it's executing close to the data. And I would really point out that although part of the API is executing in the middle tier and part of the API is executing on the E node, it's really best to think of this as a single partition service for reasons we'll get to down the road. So with that, let me switch over to the demo. And what we're looking at here is Postman, and application developers the world over like to use Postman to inspect an API, that is a web service. So in this case, since our web service is hosted on Amazon, we're doing a get. You can see that the service is looking up our price. And if we look at the parameters, we're passing in the customer name of Alphonse and product number of 1. And we're telling it that we want to get a JSON payload back that will have our dynamic price. So if the demo gods are with us and Amazon is with us, we can take a look and see that our price was $58.99 for product 1. So if we send another request, comes back, our price went down slightly. They're rewarding us for being loyal customers, I guess. If we execute up, it went up, we've depleted the inventory. So our price is dynamic. So let's take a look at how this is managed in the cloud. By the way, how many people are using an API gateway for a cloud vendor? Right? Very interesting. So really, this is just a Amazon console, an AWS console, that's publishing the API to applications, and it's handling the dispatch from applications as they come in. So any request that comes to our price dynamically service in the Amazon gateway is getting routed through message dispatch to our price dynamically Lambda. And then the response from the Lambda is getting routed back. So let's take a look at the Lambda. And again, let me ask, how many people are using Lambdas in production or even experimentation? More people are. And so a Lambda is basically a piece of code managed by Amazon. That's all it is. And you can, in this case, the Lambda is set up so it can handle API requests. So we can look at it here. Our Lambda is dynamic pricer. It's just a class, and it has a handle request method that will be receiving all of the requests from the client. And you can see that the console also gives you the ability to provide some environment configuration. So let's peel back another layer and look at the code that implemented this Lambda. So here's our dynamic pricer. And request stream handler is an Amazon class, so our Lambda has to implement the Amazon class. But really it's really very simple. It comes in two parts. The constructor does the initialization, and then handle request handles every request that comes in. So for our initialization, we're getting some environment properties so we can create a database connection. And then we initialize database services with that database connection. Now, the database connection we're getting here, this is just the MarkLogic Java API. There's nothing new or special about this. We're just initializing it so that we have a connection at all times in this Lambda. The data services, the database services object is our interface to the database. It's how we're going to be sending data to the database and getting responses back from our data services. So that's the initialization. And now let's look at handle request. So the request comes in from Amazon, and our Lambda starts by simply unmarshalling the data that's being sent from the application. In this case, the customer name, we're turning it into a string, and the product number, we're turning it into a number. The second step, and at this point, by the way, a Lambda that's not a demo would be doing things like validation of the inputs and so on, potentially some business logic there. But once we're satisfied with our inputs, with our customer name and product number, we can call into the database function to look up our pricing factors. And I think I pointed out during the initialization, we created a database services object. And this is the one that provides us with the methods that we use to interact with the database. So our lookup pricing factors database function returns the factors in the form of a reader. We pass those factors into our pricing engine. We get our dynamic price back. And then finally, we can just create a JSON object with the dynamic price and return that back to the client. So one of the important points here, and this really gets back to the value of having a partitioned service, is that our Java developer, we could call her Jen, doesn't have to know anything about the structure of the persisted data. Jen is just sending in the customer name and product number and getting pricing factors back. effectively, it's a library to her or perhaps another service. Now, this lookup pricing factors function, this is what I'm showing you is some technology that we will be releasing later this year, because instead of having to implement this function, we're able to generate this function. Jin is able to generate this function herself, working with the data service developer, Daryl. And the way it works is that they define the signature of the function in terms of its inputs. Here are the customer name and the product number, and outputs the JSON document. And MarkLogic is going to be providing some tooling that will generate the Java implementation of this function and handle all of the transport to the server. And that's what lets Jin work with a Java function without having to understand the database. At the other end of this function is an endpoint. And this is some JavaScript that's on the enode in MarkLogic that gets called by the function to look up the pricing factors. So you can see here's our customer name and product number, two JavaScript variables. And those are initialized by the MarkLogic app server when the request is received. So Daryl, who's writing this JavaScript function, doesn't have to worry about the transport or unmarshalling the values here at the data layer. So what Daryl uses these values for, he executes two queries. In the first query, he's using the customer name to look up where the customer is located and the date of the first order by the customer as a measure of customer loyalty. So those are the customer factors. And using the product number to pass it in to look up some prices and calculate for the current date. We're going to calculate how many orders have we had for this product, what was the minimum price, what was the maximum price. And we'll also join the products and figure out how much more of the product do we have in stock. And these are the factors we return to the pricing engine. What's important here is, again, that the structure of the persisted data and how you query it is completely encapsulated within this data service. So, in fact, the fact that we're executing two queries here is something that the middle tier doesn't have to know about at all. It's just passing in the information, rather the criteria, the query criteria. Nothing is restricting these queries, this script to be entirely about queries. The script could be inserting audit records as well, and the client would be completely unaware of that, the middle tier. Now, I've been looking at code that's going to be possible to write a little later this year, because we will be taking this declaration and using it to manage the transport of the data between the middle tier and the server-side JavaScript script on the enode. But nothing is preventing you from doing this today. Today, what you would likely do is the middle tier developer would actually implement this lookup pricing factors function instead of generating it. And you could use the Java API to either invoke a module, or you could call a resource service extension. At the other end, the middle tier, the data layer code would have to do the unmarshalling. It would have to deal with HTTP, but otherwise the body of the data service here would be completely the same. We'd still execute the same 2 queries. Anyway, once we've established what we need is the customer name, the customer postal code, first order, and so on, we've established the data that we need in the model to support these queries, we can determine the model. And it's actually quite simple. This is all we need to support these queries. So that's all we need to integrate from our data sources in order to roll out this first API. Now we might be tempted, we certainly know more things about the product than the amount of product in stock, so we might be tempted to put in other properties of the product. But there's really no reason to do that. It's not giving us any benefit for our first service, our first API, and by the time we use it, the landscape may have changed. We may find there may have been a merger and acquisition, and so now we need to represent product in a different way. So the thought is, the API first approach is not to get ahead of your needs, to meet the immediate requirement and be pretty disciplined about not adding more than is necessary. Okay. Now, the stack I showed you was implemented on AWS. Virtually the same stack could be implemented on the Azure API gateway. Azure has a gateway as well. The Lambda, the middle tier code would look a little different, but only to integrate into Azure. The approach is not limited to the cloud. There are open source API gateways that you can have on premise. It's not limited to API gateways. Your interface to your application could be a GraphQL server. It could be running on Node.js. The same principles of starting with the API and using a partitioned service so you can execute code close to the data where it's appropriate will still hold true. So Carla and the team roll this out, and it's a success. Their applications start using dynamic pricing, and the CEIO is pleased. That's great progress, but it's still Carla's problem because it's an increment. But that's okay. Carla understands now how to increment over rolling out these application support and new APIs. The next step is to identify the second application and the API that will support that. And in this case, the least effort to implement, the most value to the business, will be fraud detection. There's been a bit of a hiccup. The team lost its Java developer. The Java developer did too good a job and got pulled into the pricing engine, but that's okay. We can get another Java developer out of the pool of generalists, of Java generalists, and because they don't have to understand the database, the structure of the persistent data, or how to work with the database, they can be perfectly effective in writing the middle tier part of our fraud detection API. Our data service developer is the catalyst for these Java developers so that we can make those Java developers productive and allow them to tap into the rich ecosystem of the middle tier while still taking advantage of the ability to execute logic close to the data where it makes sense. So the design process for our second API, the application needs to check whether the customer is a fraudster. So we'll take the customer identifier and the amount of the purchase. We'll construct a profile of the customer and try to match fraud signatures, and write an audit record so that if the same customer hits us, we can detect that very quickly. Based on that, we know what data we need to add to the model. We need more account information, and we need to integrate more data sources to support the new model. So you can see that the practice that Carla is developing here is a cyclical one. where in each case, we identify the next application, design what we need, load and integrate the data, and continue to expand our integration and our set of APIs. This is the success picture of being in this constant cycle, adding value to the business on each turn of the circle. So in the time it would have taken the data-first approach to get to the first application, the API-first approach has launched a couple applications, and maybe we've developed enough experience that we know how to launch multiple APIs at once now. And I think what you can recognize both in this slide and in the previous slide is what we're really doing is applying the lessons learned of Agile software development to data integration. This notion of scoping your requirements to immediate needs and repeating and growing your activity and building expertise as you go. So one last point. So we've been building up our stack for our second API, our fraud checking API. And to do so, we've modified the model. So you might wonder, well, what does that do to our existing API? Well, the fact that the awareness of the data structure is entirely encapsulated within our data services means that we only need to tweak our data service. The middle tier portion of our API is still valid because it didn't have to know about the structure of the model. Now, one temptation would have been to create, instead of spinning off two services, create a single data service that both the new fraud checking API calls and the existing price dynamically API calls, and parameterize it, and we'll do what's necessary. The problem with this approach is we've introduced complexity into our data service. We've introduced complexity of dependencies. So if fraud check needs to have a tweak made to the data service, now we have to worry about price dynamically, and especially if we have reuse beyond that across the middle tier, we have to worry about other consumers in the middle tier. Instead, the better approach is to take the lesson learned from microservices and consider each of these a separate independent stack. So we get the benefit of microservices in that Match Signatures only needs to worry about supporting check fraud. It doesn't have to worry. If it has done that job, it has fulfilled all of its responsibilities. So we get that benefit of being able to treat each API in isolation without having micro silos. We still have the integrated data model, so that common model is shared across all of our APIs because of the agility of the database in being able to change the model. So to summarize the journey to success for Carla and her team, they took an Agile approach to design. In this approach, they were always limiting their requirements to their work to the requirements for the next application. They partitioned the logic so that they could take advantage of both the resources of the middle tier, our pricing engine, but also encapsulate awareness of the persisted data, its structure, how to query it, and to take advantage of the efficiency of being able to run multiple queries or perform multiple operations encapsulated within a single interaction with the middle tier. And success in this approach is iteration, is adding value to the business, expanding your set of APIs, and expanding the integrated model. We also took a look in this talk at a preview of something that will be coming out later this year, is some tooling to make it easy to have those partitioned services. So it can more easily support this API-first approach. Basically, you declare a database function in a JSON file, then you can use tools to generate the Java class, and the app server can take advantage of that declaration to do some of the work for a main module. But of course, the most interesting thing is how these approaches apply to your business problems, how they play out in your own work. And with that, I'd like to open it up for questions. And I believe we'll have a microphone available to people.
Yep, I've got the mic. Just hold up your hand if you have a question. Don't be shy.
It's always hard to be the first.
Anyone? Here we go. I'll pass this down to you.
So in the pricing example, you had the function call to return the price. You also had the SJS to return the data. I'm not sure where I saw that the logic to create the price. Where was that sitting? Was that the middle layer? Because it sounds like it should be there versus in the server.
It is. I perhaps skipped over that rather quickly. So here's where we call our pricing engine. So it's in the middle tier. So the main module is looking up the factors. It's not trying to be the pricing engine. You know, when you first get a sense of the power of MarkLogic, it's tempting to think that the answer is always, oh, we'll port everything to MarkLogic. And I've been guilty of that thought. But in fact, there's no reason for our pricing engine to move to the eNode. It's perfectly valid where it is. We don't need to incur that work. Does that make sense? Okay. Other questions? Yeah.
There you go.
Yeah. Hi.
Hi.
Our use case for MarkLogic is to use it as an operational data hub and return the APIs, and we use IIB for enterprise bus that talks to different applications. And our current architecture is to build generic services out of MarkLogic and let IIB serve what each individual consumer wants. And versus MarkLogic determining what each individual consumer wants and provide, and IIB just acts as a pass-through. So which one of these two approaches is?
I think, both are valid architectures. Certainly you could use MarkLogic as the source of messages that you construct and propagate out through the enterprise bus. That's valid. The reason this approach is very appealing is because it does the most for encapsulation of the database and thus promotes the most agility in the movement of the model. Okay. Other questions? Or if I'm channeling Mary, comments, denunciations would follow soon.
Hi. So you mentioned about when we start developing the applications, first start with the use case and then start building the model and then have your data structured accordingly, right? It may not be possible every time you build applications to gather all use cases. So let's say you have another use case and then you have another use case, like, for example, get price for certain departments or certain level of customers. Mm-hmm. And if it needs a change in the model, would that be a bigger problem to solve? Because it can disrupt all other services. How do you solve that problem?
So it's a good question. And I think our reasoning on this is you have the most flexibility in evolving your model when you create data services. That's the point at which you could absorb changes to the model. Not all changes to the model are going to affect every service, of course, but where a change, for example, with our customer data, if we had to, for purposes of some other application, we had to create split the customer name into two different fields. For example, we could make that change in the data service. There are other things we can do to accommodate evolution of models. We can version the model, continue to access the old version, and while we're rolling out the new version, and then gradually, incrementally over time, port from the old version of the model to the new version. And that's certainly a feasible approach.
Right. Right. So basically, in greenfield applications, this fits perfectly well, this kind of approach. But eventually, what happens when you kind of build a monster, it then starts the reverse approach, saying that we already have the model in place, and that's the problem we face. So that's why I was asking.
Well, I think, so yes, the larger a model gets, the more complex a model gets, the more careful you have to be with it. I think what I would emphasize is that because it's a document model, it can evolve in ways where the same document can have both the old and the new version of the property. So you can continue to support the old consumers and the new consumers in the same document, and then gradually over time reduce that redundancy. So the flexibility of the model is huge. Does that make sense?
Yeah, thanks.
Okay.
Anyone else?
Okay, I think our work here is done. Thank you for